Hi, and welcome to TEMEKO. In this video, we will continue to discuss the concept of linear impulse and momentum, but this time from another point of view, which is conservation of linear momentum for a system of particles. During the video, we are going to learn how this conservation of linear momentum is defined, and also how it can be applied to solve different types of related problems. Let's get started. In the previous video, we learned that an impulse, of which the magnitude depends on the magnitude of the applied force on the particle and the applied amount of time, can cause a rate of change in the particle's momentum. In other words, the particle gains velocity because of the applied force, and this velocity is also dependent on how long the force is applied on the particle. Now that we are looking at the system, it usually consists of multiple different particles. So think about this. What if we want to use the same principle as in the case of a single particle to solve the velocities of the system of particles at certain time? How could we achieve this? Well, to achieve this, we would have to consider all the particles with their mass and initial velocity and also all the external impulses which are acting within the system. We can express this mathematically as follows. Note that if there are only internal forces affecting the system, our equation gets simplified because of Newton's third law, which dictates that the internal impulses which are acting within the system between the interacting particles gets to be eliminated from our analysis. This equation is what we call the conservation of linear momentum, which we use most often when we want to analyze the collisions and interactions between different particles. It states that linear momentum for a system of particles will remain same during the investigated time period. It is important to keep in mind, however, that the conservation applies only in the case where there are no external forces. Of course, if the external force doesn't have a significant effect on the change of the particle's linear momentum during the short period of time, then the conservation of linear momentum also applies. We call these types of external forces, in this case, non-impulsive forces. On the other hand, if the external force has a great effect on the magnitude of the particle's final linear momentum during the short time period, then it's called, instead, impulsive force. Now that we are familiar with the concept of conservation of linear momentum, and we also know in which situations we can apply it, let's go through the basic steps that we can use to solve different related problems. The first step is to establish a suitable inertial frame of reference and draw the free body diagram of every particle in the system so that it's possible for us to identify all the internal and external forces. After this, we establish the direction for both the initial and final velocity of every particle based on our assumptions. After we have drawn the necessary diagrams, we can start to apply the conservation of linear momentum in the appropriate direction. And that's it. These are the steps for solving the problems related to conservation of linear momentum for a system of particles successfully. Hopefully, after watching this video, you know how to define and in which situations we can apply the conservation of linear momentum for a system of particles. You are also familiar with the steps to solve a different variety of problems that are related to this concept. Thanks for watching and have a nice day.